All right, 1-3, properties of real numbers. I think that's what it's called. That's what we're going with. First thing is, who knows what commutative property is? So let's break that down. What does it mean to commute? Does anybody have an older brother or sister in college?
Yeah.
All right, where do they go?
Westchester and
Fantastic.
Kutztown.
Do they live at Westchester?
No.
No. So what is it called when they drive there and then they drive home? What's that word? Starts with the C.
Commute.
A mute. What was it? Somebody said it.
Commute.
Commute. So that's what the commutative property is. It means numbers are going back and forth. So in short, let's switch it to, you can switch numbers back and forth with addition and multiplication. So just so you know, I don't like using formal math definitions because they mean nothing to you guys. So I like using definitions that mean something. So the commutative property means you can switch numbers back and forth when you're talking about addition and multiplication. So like in essence, order doesn't really matter, meaning 2 plus 3 is equivalent to 3 plus 2. Notice the order doesn't really matter there. And likewise, let's say 4 times 2 is the same thing as 2 times 4. And why would I want to know this, or why would this be useful to me? Well, I will throughout the year reorder things to kind of make my life easier. Okay? So what does associative mean? So what are the people that work with you? What are they called?
Co-workers.
Yeah, what's another word for coworkers? It starts with an A.
Associates.
Yeah, so associates are people that you work with. So in math, when we're talking about the associative property, we're talking about grouping of numbers. Doesn't matter with addition and subtraction. Or not subtraction, multiplication. So what do I mean about this? Well, if I have the numbers 1 plus 2 plus 3, well, let me write 1 plus 2 plus 3 on the other side. If I add 1 and 2, I get 3 plus 3, that's 6. And it's the same thing if I do 2 plus 3. All right? And likewise, if I were to change that to multiplication, that would be really helpful to me, okay, later on. And you'll see when I give you guys your extra credit problem in like, I don't know, 15 minutes or so. The identity property, okay? So the identity property is pretty much how you get back the original number. So what do I mean by this? Well, for addition, if I start with 5 and I add 0 to it, I get back 5. So the identity property for addition, or the additive identity, would be 0, okay? And then for multiplication, it would be 1. because 5 times 1 is 5. So the multiplicative identity would be 1, and the additive identity would be 5. So going along with that, the additive inverse is, in essence, or in short, how you get back to 0. Okay? So in my example of 5, the additive inverse would be -5 because it's opposite. It's how I'm getting back to 0 where I started. Okay? And the multiplicative inverse is the reciprocal. It's how you get back to 1. So for ours, it's 1/5, because that's going to get me back to 1. And like I said, these aren't formal definitions. I'm going to post my formal stuff on Schoology at the end. But what I try to do is I try to break these things down to kind of relatable terms. And the distributive property, Jake, if I asked you to distribute a stack of papers in class, which we can't do right now, what does that mean, Jake?
Wait, if I can't distribute papers?
Yeah, what does it mean if I ask you to distribute a stack of papers?
I'll give it to everyone.
All right, so here, the distributive property is, in short, we're going to give that number to everything, okay? And these are Jake's words, not mine. And this is what it looks like. If I have 2 times x plus 1, the distributive property is going to be, I'm going to distribute that 2 to the x and to the 1. So it's going to be 2x plus 2 times 1. And you can see how that kind of makes sense. Cody, you with me, buddy? Good. Franklin, you there, buddy?
Yeah, I'm here.
All right, cool. Franklin, help me out then. Okay. So I know I gave you some rinky-dink definitions here. Okay. They were kind of basic. But I really think if you break it down and you think about it and look at them, I think they make sense for these problems. When you're looking at A, which property, which one of those properties in the top half of the page are we talking about?
Distributive.
See? So we distributed that 4
Mm-hmm.
to everything.
Mm-hmm.
Too many. And Julie, what property would B be?
Is it associative?
Very good.
Wait, can I go now?
Because notice the numbers didn't switch places. They didn't move around. We just grouped them differently. Okay? What about C? Let's go with Amelia.
Multiplicative inverse property.
Yeah, multiplicative inverse. And the last one, Ed. Little tricky. What do you think that one is?
Commutative.
The what?
Commutative?
Well, did the numbers move around, Ed?
No.
No. So what number stands out to you in D?
Negative through B.
B stands out to you? Well, notice there's a B on both sides, so it's not really different. Doesn't really stand out.
0.
0 does. Now, which one of our properties talked about 0?
Identity?
Identity. So this would be the additive identity. All right, of addition. Okay? So let's go down here. Now we have these two properties. Okay? Additive or addition property of equality and multiplication property of equality. What is the addition property of equality? I think you guys have heard this 1,000 times, okay? In short, both of these things are this. Anybody want to finish that statement? How about now?
Whatever you do to one side, you do to the other.
There you go. Whatever you do to one side, you must do to the other. So why do they only talk about addition and multiplication? Well, subtraction is really just adding the opposite. And division is just like multiplying by the reciprocal. So that's why they only talk about addition and multiplication here. So in short, it's whatever you do to one side, you must do to the other. And we use it all the time when we go ahead and solve an equation. So how do I solve 3x plus 4 equals 10? What would my first step be, Lance?
You gotta get the x to be by itself.
So how do I do that?
Subtract 4 on each side.
All right, and that is the additive or the addition property of equality. So I'm adding the inverse, essentially. I'm adding a -4 to both sides. But we know that is subtraction. So we have 3x equals 6. Now what do we do?
Divide by 3.
And we're going to multiply by the inverse. We're using the multiplicative inverse. And that's where we get x equals 2. Are you guys okay with these things? I know you've seen it 1,000 times, but do you have any questions?